Before we totally get into section 3.3, we're going to quickly review the change of base formula, which we actually wrote down earlier. But it's one that you definitely saw last year as well, and you used. Yes, you all found that cool log base b function in your calculator, little cheaters, but the change of base formula can still be helpful. But then there were other properties last year besides the inverse property and besides the one-to-one property. There were other properties last year besides the change of base formula and besides the one-to-one property and the inverse property. We're going to see them in just a second. They're the product property, the quotient property, and the power property. And we kind of saw one real quick at the end of yesterday. I said, hey, do you guys remember there's this property, the power comes down? And some of you were like, oh, yeah. So as you guys are writing your notes, I want you guys to go quickly back and find for me that change of base formula and fill it in. We're still going to need it. Go find it in section 3.2. What was that change of base formula? There are a couple different versions, so I like writing them all down. One is the general one with log base b. The other one is the more specific one. An example of ln. Start with a log base n. How does it work? You guys find it? What's on top? It's always a fraction. Good. Log base, the new base, whoever you want it to be, we'll just call it b. Of who? X. Take the x first. We're just taking it apart piece by piece. Then over log base, your new base of a. And then I said, hey, we can make this specific, especially for poor people that have only the yellow button on their calculator. They don't have log base b in their math menu at all. They can use this because if they want to solve, say, log base 2 of x, they can just use the ln button and do ln of x over ln of whoever the base is that they can't plug in their calculator. Or they could use the common log button of x over common log of a. And technically we could do that with any base and make it log base 3 of x over log base 3 of, ooh, who was I supposed to put? So these are just specific examples of using this property. Okay, change of base. We're just going to need that at some point today. But first of all, discovery. Okay. Before we go into this discovery, let me take just a second and make a little bit more room over here to the left. Let me actually just zoom in one. I want us to quickly review exponent rules. I don't think we've actually written these down anywhere. It was one of those, like, theoretically you've seen since Algebra 1 that doesn't necessarily mean we've mastered it, like FOILing or completing the square or factoring. So maybe we should review real quick. Exponential rules. And I don't mean, like, wrapping an exponential function and figuring out what it is and all that. I just mean simple stuff. Like, if you have x to the a times x to the b, what happens to the exponents? Or if you have x to the a over x to the b, what happens to the exponents? Or if you have x to the a all to the b, what happens to the exponents? Those ones, the easier ones, right? Let me zoom in, it's kind of small. Exponential rules. You guys know these from algebra, yeah? Remember if you had x to the a, you would write x so many a different times, and then write x b different times, and then add the two. Add the two. What's the new power of x, guys? A plus b, right? And then this one, exponent rules, you would have x written a different times multiplied together, x written b different times multiplied together, and then you could cancel out, and you would have how many x's left? X to the however many A was minus however many B was. Right? And then if I have x to the A to the B, so I have x to the A written B different times. X to the, raise a power to a power and you multiply. Some of you know that. Raise a power to a power and you multiply. So x to the A all to the B, x to the AB. And since we're writing down exponential rules, let me just do one more. Let me do two. What if you had x to the negative A, you can't call it negative, x to the negative A, and then 1 over x to the negative A. Let's just review negative exponents real fast. How do you rewrite x to the negative A in positive exponents?
1 over x.
Good. And then how do you rewrite 1 over x to the negative A with positive exponents?
X A.
Remember, the negative just says he doesn't belong where he is. Put him where he's supposed to go. He doesn't belong up top. Put him in the bottom with the positive, or he doesn't belong in the bottom. Put him up top with the positive. If you actually want to see why, you can kind of make this an x to the 0, and 0 minus negative A would be a positive A. Well, that's fancy. You can technically put this one over x to the 0, but that's a little harder to see. Okay. Exponent rules. Why did I review that? Well, because up here in the discovery, we're looking at an exponential function. And the exponential function in the exponent has a plus. Can you guys tie that plus to one of these rules? Kind of, right? So if I take this, and if I think about this rule, and if I ask myself, can you go backwards? The answer is yes. This is commutative. It works either way. Well, it's a little bit harder. But how could we rewrite this?
A log A U times A log A U.
The addition came from the multiplication of 2. Now, why is that? The addition came from multiplication of 2 different exponential pieces. Nathan, what can you do? Yeah, and someone adds to that, why can you just cross off stuff? What property says, oh, hey, they undo each other? Oh, no, not one-to-one. Undo, I heard someone say it. What undoes, not the one-to-one property. Inverse. So then, those cancel out in essence, and you just get U. Those cancel out, and you just get V. Wait. What? So, we could say the following. If this whole snazzy, complicated expression just equals U times V, which is a lot easier than what it looks like from the beginning, we can make the following statement. We can say, all right, so A to the log base A of U plus log base A of V equals U times V. Sure, we just showed that. Then we can say, well, you're way more complicated than you're supposed to be. So let's go ahead and undo that exponential. How do you undo? You undo a logarithmic by putting, an exponential by putting in a logarithm. Those are going to undo each other. Log base A of U plus log base A of V equals, wait, I did something super illegal. What did I do? I wrote in on one side, but I didn't do it on the other. Oh, struggle. What did I do to one side? Maybe we should make an animal about that, huh? I'd write that.
Yeah, every time
An ostrich.
the ostrich thing.
I was worried about the math. What I was in the animal. There's plenty of those, right? We'll go to the zoo. Okay, so I took log base A at both sides. Oh. Hey guys, does this property look familiar at all? Log, a single log of a product is the sum of 2 separate logs. I think that's a property. Let's go go find him. He is private property. You saw him last year. Oh, we should be writing because there's stuff on the board that's new. There are 3 properties. Technically, I could have gone through and shown you each of them. Well, you guys are writing. I'll show you the other ones on the board while you're just chilling. Well, you're not chilling. You're writing. I would have been chilling. I'll show you. It would just be using exponent rules. You're not writing what I'm writing. You're writing that. 3 big properties from last year. Is that a property? Quotient property. I have one more to show you. Keep writing. You do the end. I got stuck because this one's kind of boring. I proved something, but not something very exciting. Come back to him. I proved something wrong. I mean, I proved it right, but it's just not getting all the way there. We'll come back. But some of you are bound to somewhat be like, oh yeah, I think this was a thing last year, and it was. 3 different properties: the product property, quotient property, and power property. The product property, quotient property, and power property. You guys might be a little confused because hopefully you wrote it down correctly and you have 2 different ones. Remember, when they're giving you the natural log, just kind of like what I've been doing, they're just giving you a reminder of, hey, ln is a log 2 also. So yeah, this one's for any log, and then hey, ln, he's a log, don't forget. That's basically what that side's for, okay? So then when we get down to problems like these, which are a little bit harder than they were in section 3.2, and they ask us to rewrite and then simplify. Well, I mean, I guess we could just change the base and do something like, all right, fine, let's just change it to log base, I don't know, 10. Yay, look, it's rewritten. But is that simplified?
Yes.
for the people with yellow buttons on their calculators. I mean, I guess they can get a decimal, but that doesn't really help us simplify it in the sense of break it down. Now, hold on. Can I rewrite 8 as a power of 4 like you did in last night's homework, some of it?
Yes.
No.
Can I? 4 to the 1 is 4, 4 to the 2 is 16, 4 to the 3 is, Well, if I can't rewrite, is there a 4 in 8? Okay, so hold on. What can I rewrite 8 to be?
2,
2 times.
4.
Oh.
That's weird.
I wonder what they want me to do.
Product property.
Now I have a times. Read it. Log base 4 of 2 times 4. Oh, that's product. Okay, product property. Log base 4 of 2 plus log base 4 of 4. Can I simplify any of that?
Yeah.
Yeah, from last night's homework. Hopefully the log base 4 of 4 thing is kind of ringing a bell. What happens when you have log base 4 of 4 to the 1? It reduces, careful, cancel. It reduces to be what? 1. Canceling, you like to use that when it goes to 0, like 5 minus 5 is 0. Cancels. Reducing helps you remember it's a 1. Now, here's the struggle, kiddos. The final answer, if you plug and chug this into your calculators, is 1.5 or 3 halves. Well, how on earth do they get there? Hold on, pause. Give everyone in your group high 10. High 5 is not going to cut it today. People are falling asleep. Hurry, go.
Yeah. Wait,
Wake
this is
'em
like
up.
a high. Is this like a slap?
No, high
Yes, it
10.
is.
Oh my goodness.
Ricky,
He's not even in your group.
Oh, you're not in the group.
All right, here we go. Come back. Don't worry, calculus needed it too, but their room is much warmer. Guys, what do I do with log base 4 of 2? Can I rewrite 2 somehow in terms of the power of 4?
Square it.
Not square it.
Square. Multiply it by itself.
I can write it as, now hold on, if I just square, listen. If I just square 2, I'm not doing anything because what I do to one side I have to do to the other side, and I don't even have another side, so that's illegal. But I can say, what equals 2 that has a 4 to a power?
What?
I'm so confused.
What if I write it like that? 2 equals the square root of 4, and 4 square rooted is the same thing as, remember from last night's homework? 4 to the what power? Oh. Now that took a little bit of mental brain power, right? But if you think about it, if you can say 2 is the square root of 4, then Jason, focus, I can rewrite it as, rewrite it 2 as the square root of 4, and then when you square root 4, you can write 4 as the 1/2. Hey, what happens? Log base 4 of 4 to the 1/2 equals
1/2 under 1.5.
1/2. So I guess, even though you might not have thought of it on your own, my question is, does it make sense that 2 is the square root of 4? Is 2 the square root of 4? Okay. So pause. That's all you need to understand. Is 2 the square root of 4? Yes. Why on earth did she? Oh. Because then log base 4 of 4 cancels. I just get 1/2 and I go. JJ.
How'd you get 1/2? Log base 4 of 4 equals 1. So then you get 1 to the power of 1/2, which is 1.
Technically, our property from yesterday said log base a of a to the x equals x. That was our property from yesterday. Go look in your notes from yesterday if you need to. You can look at it again. You used it in homework last night. We had a problem. Log base 9 of 9 to the 15 was 15. So whoever's up there is the final answer when you cancel them out. So log base 4 of 4 cancels to be 1/2. Well, why was this one 1? What was the power of 4? That makes sense? So log base 4 of 4 to the 1 is 1. Log base 4 of 4 to the 1/2 is 1/2. It's whoever's in the power. And if it's not written, it's an understood 1. Good? Okay, now, number next one. Let me zoom in a bit. Some of you in the back, maybe you're just not seeing it so good. Question. What property, and if some of you need this quick little kick in the pants, You might not be able to use your calculator on this test.
What?
Oh, so we're actually supposed to be learning?
What's learning?
Come back. Some of you have dealt way too much on that crutch and you're like, oh, I just forget it all and still ace it. Come back.
Can you use a slide rule?
That's funny. Come back. It's cool. I have mine too, but no.
Jason has one.
Jason Johnson, yeah, he's just a. Okay.
She's making a slide rule.
This is log base what?
10.
There is no base. Oh, it's common log, and common log has a base of 10. Okay. Is 9 over 300 a power of 10? Who knows, right? That's weird. Okay, so hold on. What property? Product, quotient, or power? What property helps us break this
I
down?
feel like it's quotient.
Quotient. Quotient property says log of u over v equals a log of the top minus the log of the bottom. Keeping the logs the same as the original. Okay? How did that help?
Magic.
Question. Do you see anything in common between 9 and 300? And maybe we should ask this question.
3 and 9 are like things.
We both have 3s, right? Wait,
Yeah.
what did you say? We're 3s.
3 and 9 are like 9 3 or 9.
Yeah, okay. So you see in 3s. I see 3s too. Do you guys see 3s?
Yes, I do.
Okay. So what if we were to rewrite this as log of 3 squared minus log of 3 times 100? I'm just showing where the 3 is, right? No, hold on.
Is that possible?
Is it 3 times 100, 300?
Yes.
We're okay on multiplication, right? Okay, and 3 squared is 9. Good. Question. What properties? We're just looking. What properties can we use? Well, power property. Bring down the 2. So I have 2 log base 3. Minus. What property can I use for this one? Product, maybe? True? Right? Now, why did I put parentheses? Because I'm not trying not to kill a seal, right? You guys in the back care about the animals, true? Please. So, I need to say subtracting this whole thing, so subtracting the sum when I break it down. Now, how on earth does this help?
I don't know.
Look at your properties. I just used the product property. Log of one times another is log of one plus log of the other, right? The product property then. Okay. I can distribute that negative. 2 log of 3 minus 1 log of 3. They're common. Minus log of 100. Okay, what can I do with 2 log 3 minus 1 log 3?
Get rid of the log minus log 3.
I can't get rid of the log, but I can combine my terms.
Or you get rid of 1.
What's 2 minus 1?
1.
Okay. Log base 3 minus. Is there anything special? With log base 10
Oh,
of 100.
it's 2.
Oh, yeah.
100 is what power of 10?
2.
10
So the 2.
squared. So I can rewrite this log, and if you need to, you can wait till 10 for a second to help you and say, hey, it's log base 10 of 10 squared. And we've been working with this one over here, remember? When we have a log of a base with the same base to a power, the inverse property says what's left?
2.
Good, the power. Oh, you guys realize I wrote my poor little 3.
Okay.
Yeah, I was wondering why you did that.
I don't know. Wrote in the middle instead of big. Yes. Do you think maybe in all my grading of all my years of pre-cal, which isn't as many as some, but much more than you, do you think I've seen people write little numbers as big numbers and big numbers as little numbers and get confused?
Yes.
So be careful. Okay. Now guys, last thing. What do you think would be one of the most common mistakes of kiddos that solve this perfectly right up until this step? They're
Log
like,
of 1.
log of 1. So how should we rewrite this to save ourselves and others from that mistake? Because this is in a log and that is not. That's okay, but still not great. Because this is still pretty stinking confusing. It's not 1.
Man, why did you just say like that?
Is this much clearer that they better not combine?
Yeah.
Yes. Awesome.
Hey, why didn't you put a negative in front of the wrong part?
Oh, because I had 2 log 3 minus 1 log 3, they're just like terms, so 2 minus 1 is a positive. Does that make sense? So it's like a 2x minus a 1x is 1x, except it's 2 log 3. Good question. I combined my like terms. Now, here's a dilemma, kiddos.
Wait, why is this up?
To be honest, these are kind of abstract problems, right? Because they didn't exactly go perfectly. We kind of had to dig to even figure out how to use the properties. Let's get some that are a little bit clear. Let's get some directions that are a little bit clear. Let's get some problems that are a little bit clear. And either you're tearing it down, you're expanding, you're breaking it apart, you're pulling it apart, or you're pushing it together, but it has to be with the properties. You're either pulling it apart or you're pushing it together, but you have to use the properties. Technically, kiddos, I have section 3.3 as being started today and finished tomorrow. We're not going to need all of tomorrow to finish it, but some of you, here's the dealio, you probably need a couple nights for this homework. So the homework is due on Thursday, listen. But we're going to start section 3.4 tomorrow. Because 3.4 gets a little harder. But I wanted you to have a couple nights to work on this foundational lesson first, okay? We'll take a couple days on 3.4. It won't be long. Okay, so they're spread apart. But you need to start this homework tonight. Because I don't even want to touch 3.4 until you kind of work with it. Remember, just like anything. You can watch a great basketball player all day long, but until you start trying it for yourself, you're never going to be able to play it, right? You can't just watch someone and be like, oh yeah, I'll be just like that. It doesn't work. You can watch me all day long and be like, all right, fine, whatever, but if you don't try it on your own, how are you going to learn it for yourself? Now, expand. Okay, that makes a sense, hopefully, in the sense of we're making it bigger, we're making it broader, we're pulling it apart. But how are we pulling it apart? We're taking a single logarithm, 1 log, of basically some sort of packed argument. There's a lot going on. 1 log, in case I just covered it up, it's log base 4. Of a packed argument, of a condensed argument. And we're trying to expand, we're trying to pull apart, but we have to use our properties. Now the problem is our properties say, like in this one, our properties just tell us 2 things, and they say, oh, okay, if you're dividing 2 things, it's 1 subtraction. If you're multiplying 2 things, u times v, it's 1 addition. But then you get to a problem like this, and you're like, oh, stink, there are 3 things. But the property still applies. Whenever you have multiplication in an argument, you can pull it apart, you can expand to have addition of logs. So here's how you do it. Every time you say times, it becomes a plus of another log. So first of all, log base 4 stays. He's our log. He's our guy. We're going to keep using it. Log base 4 of who? 5 times, I write a plus. Log base 4 of 5 times, I write a plus. And I say, oh, time for a new log. Okay, who is after? Log base 4 of x cubed times, I write a plus. New log. Log base 4 of, what did I do? I used the product property and said, oh, every time there's a multiplication, I can add a separate. I can expand into a new logarithm. Same base, I keep the base the whole time because these are guys. But I expanded it apart. Now, this argument was super complicated. 5 times x cubed times y. Now it's just 5, just x cubed, just y. And there's just one that I can make a little bit easier, simpler in the argument.
Look where it's doing x.
I can say the power can come down. I can just call this 3 log base 4 of x's. You might have picked that a second ago. The goal of expanding is making what's inside the logarithm as simple as possible. I just have a 5, I just have an x, and I just have a y. Dun, 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 dun. That's as expanded as I can go.
Yay.
So on the next side. The big picture, I know there's a square root, but the big picture. I see a division, don't you? So whenever you say divide, you say subtract of, expand to a new log. So ln of, well, use ln, he's our guy. Of the top, all right, rewrite the top. Divided by, I change it to be a minus. Expand to a new ln. Divided by who? 7. Now this is a little better. There's no division anymore inside either of the logarithms. There's this square root thing that I'm thinking maybe I could do something with if only I saw him instead as a power. For those of you that might need to see this step, a square root is something to the first power square rooted over 2, 1/2. This is just an in-between step so that you realize why in just a second I'm going to pull down who? The 1/2. Now just a few of you are like, I can go more, but the sad thing is you can't. This is a struggle. Listen to the person who knows and has seen the mistake made over and over. What do you think people want to do when they see this subtraction? They're like, minus, make it division. Division inside a single is subtraction of 2 separate. There is no rule for subtraction inside a single. You can look at your properties. That's not there. There's a property for multiplication inside a single, division inside a single, and raised to a power inside a single, but no property is for subtraction. You gotta stop. There's nothing else you can do. But it's still a lot simpler in the sense of who's inside the logarithms. It's a lot better than it was a second ago. Now, that's expanding. We're going to end with condensing. Expanding, pull it apart. One log with a messed up or at least a very condensed argument. Lots going on, needs to be pulled apart. Condensing. It's all spread out and I got to bring it together. I have to bring it together. So, if you think about it, expanding goes from, and all the properties you wrote down, goes from the side of a single log to the side of the split apart logs with sums and differences, etc. Condensing goes from the side of the spread apart logs back to the brought together logs. You gotta be careful. There are some places where you might mess up on this one, even if you know the properties really well. And one of them is we cannot put logarithms together if their coefficients are anything but 1. Which might sound kind of shocked. So the very first thing you should look for. I'm just going to show you with one example. We get to do a few more examples tomorrow. There's a number in front. Guess what key should become first?
Power.
Then I can go ahead and say, hey, there's a subtraction, so I can divide. But I had to get that coefficient as a power first. Thank you, kiddos, for hanging in there. We got examples of every big idea in 3-3. Start that homework. We'll do a few examples tomorrow. Maybe do a few homework questions. And then go to 3-4. See you guys later.
Yes, Teddy, better? No problem. What's your problem?
Well, I did a piece of note
Yeah?
on outside of my book,
Yeah.
so now I'm gonna have to completely tape it in as a new page.
Yeah, I have done that before.